Good morning, everyone. Good morning, folks. I think so. Everyone are doing good. So this is Adarsh here from Bepractical Tech Solutions, and I would like to welcome you all for the secret blueprint for highest paid data science career workshop. And majorly, ladies and gentlemen, welcome to our data science webinar, where we are about to embark on an exciting journey into the world of data science. Our next segment promises to both insightful and educational thing, as we have the privilege of hosting a distinguished speaker who is a true expert in this field. Allow me to introduce KP Asharani, a dedicated computer scientist with an impressive academic background. She began her journey with a bachelor's degree in information science and engineering, and then pursued masters in computer science and engineering from NITK. Currently, she is working on her PhD in the same field. Asharani is not just about academics. She also teaches as an assistant professor at Dr. Ambedkar Institute of Technology, that is located in Bangalore. Her influence extends to research, where she has written many papers, even earned a patent for her innovative work. Her research interests are exciting. So she is not only into the teaching field, and she is into advanced tech like artificial intelligence, machine learning, and deep learning. But what sets her apart is her focus on these using technologies to improve the agriculture and farming methods. Today, Asharani is here to share her expertise in data science with all of us. I have no doubt that her presentation will be enlightening and informative, as she guides us through the fascinating world of data science. Without further ado, it's my great pleasure, ma'am, to hand over the virtual stage to our distinguished speaker, KP Asharani. The floor is yours, ma'am. Please go ahead and enlighten us with your valuable knowledge and your insights.
Thank you, Adarsh. Thank you so much.
Yeah, and another one thing I would like to mention, folks, in between, I am going to share a drive link where you are going to get all the files which are required for this workshop. Please do download this. Sorry, ma'am, sorry to disturb, and over to you, ma'am. Thank you so much.
Thank you. Is the screen visible?
Yes, ma'am.
A very warm welcome to the world of data science. As Adarsh introduced myself, Asha Rani, I'll be taking you a walkthrough to the world of data science. On the whole, the agenda is planned like this, wherein initially we'll explore some of the terminologies in data science, followed by Python for data science and some of the libraries which are essential for going ahead. And finally, we'll also brief about the basic fundamental concepts in machine learning. And what exactly do we gain out of this, and what all we will be learning in from this particular session would be, firstly, we should understand what exactly is a data science and how many different types of data science projects are done, and how is it possible through different technologies and tools which are available. And finally, we end up learning data science and how we are supposed to learn particular concepts. Finally, we'll have a brief insight on the career path for data scientists. Okay, coming to this fancy or exciting world, which is nothing but data science. As we all are aware of this particular terminology, we know what is data, we know what is science. What is it collectively called? What is it? This is ruling the world now. And what difference does it make when they are together, data and science on the whole together? Let us try to understand this through an analogy. And we are very inquisitive about detecting something. Whenever we consider about detecting something, it involves some of the terminologies. For example, what is that we are supposed to detect? I have to find, or I have to dig deep into a mystery. I have to solve a particular mystery. I have to throw lights on a mystery. And to do this, I need an evidence. Once I collect different set of evidences or clues, I'll try to analyze it. This is a set of sequence of process or the stages which on the whole we follow to end up solving a mystery. So once we analyze, we will try to dig deep wherein I have to investigate a particular crime scene. And from all this analysis and investigation, we'll try to estimate something or we'll try to build a hypothesis. Once a hypothesis is estimated, how far it is true, what is the evidence that whatever hypothesis has been built is true, it has to be tested, the evidence has to be tested. Once if it goes through severe testing, then based on the accuracy or the assumptions that has been made, the mystery will be solved. Once the mystery is solved, what exactly is the next step? I have to convey this process or I have to report it to the higher officials. So the reporting comes into picture there. Finally, this becomes a learning process wherein from this particular case or this particular complex mystery, we have learned something and it will be used as a experience for the next further cases. This is just an analogy wherein we come across in our day-to-day life. And let us try to relate this analogy to the concept of data science. How is this mystery related to data science? How can I relate a data science with respect to this particular analogy? Let us consider data science as a detective with clues. What we will be detecting for? We'll be detecting for clues or evidence. And what a data scientist has to do, he'll be dealing with the data. So imagine that you have data as a series of clues. So here with respect to this analogy, the clues are treated as, or the series of clues which are scattered, they are treated as a data. And let us treat a detective as a data scientist. And what this detective will do, he'll collect the data, he'll analyze the data and connect these clues. What for these process has to be done? Because we have to unravel the mystery. I have to break the mystery wherein I have to solve a specific problem by making or building a hypothesis. Then ultimately we'll be providing insights into the mystery wherein that mystery gets solved. So whatever a detective is doing here, he is following set of process. The same thing will be referred here as a data scientist. If detective is going with the sequence of clues, what a data scientist does, even he'll be dealing with the data. Here with respect to detective, we say it as a clue or a series of clues. Here a set of data or a large data set is handled by a data scientist. Keeping this in mind, a layman terms will be using it as a mystery or a evidence or evidence analysis. With respect to data science terminologies, the technical terms what we'll be referring is basically we start with the problem statement. A mystery is referred as a problem statement. From the mystery, I'll try to extract. What is that I'll try to extract from the problem statement? Basically, you need to have a very clear, well-defined problem statement. Once the problem statement is understood, I'll try to extract data out of it. So what is data here? Whatever evidence or clues we had referred, the same thing is treated as data. Now, once the data is available, I have to analyze the data. What do you mean by analyzing with respect to data science? We'll be cleaning the data. And it is one of the important steps wherein even though you have a large set of data, I cannot immediately start working on the data. I should analyze an evidence in the same way. I have to clean the data with respect to handling the missing values if some of the values are missed or if there is any duplication. These kind of analysis has to be done with respect to data. That is referred as data cleaning. Then we have something called as data exploration. It is basically referring to the concept of cleaning the data. Along with that, you need a clear understanding of the data. Once the data is ready, you need to have a clear understanding of the data, and this we will try to achieve it visually. Finally, once the data is clearly understood, it has been analyzed through the cleaning process and visually clarity is obtained. Once all this is done, we will be able to estimate the data. wherein we can build a hypothesis based on the available data. This process is termed as modeling. Now, once I have estimated or the modeling has been done, it means that the model has been trained to work on these data. I have to test it, how far the model has learned the data. So this can be done through a process called testing and validation. Now, once the testing and validation is done, I'll be looking for the accuracy, how accurately my model can predict the values. Based on that, I'll say that the mystery has been solved. It means that I have thrown light onto the mystery. So that we refer it as we got some insights out of the data. We had a large data set. We have performed some operations onto the data and we have got some insights out of the data which is available. And it has to be communicated. It has to be reported. This is a process wherein the communication part comes into picture and it is a continuous process. And this continuous process is through an experience. Whatever learning we have obtained, it is through the experience. So these are some of the stages that we come across in any of the data science project. Now coming to the definition, actual definition. So we have started relating the concept of data science with an analogy. So as per the analogy, what exactly is a data science? What did we do with respect to this detective case? It is basically a process of using data as clues and evidence. So what did we do with these clues and evidence? We were trying to solve a real world problem. And what did we do with that particular problem? We have uncovered the valuable insights. It was a mystery. Through the clues and evidence, we have uncovered the valuable insights. So it is basically a problem wherein you are detecting something. Now, coming to the technical aspects or the exact definition of a data science, we define it like this, wherein data science is the process of getting useful insights from the raw data. However you get from whichever sources, it is treated as a raw data. So you are getting useful insights from the raw data. This process is nothing but your data science. And what does it include? Basically, it includes statistical analysis, data pre-processing, data analysis, data modeling, and machine learning. So these are the terminologies which comes together whenever you are defining a data science. So data science is not a one single term. It is interconnected to so many different fields, wherein it gets connected to statistical analysis, it gets connected to data pre-processing, data analysis. You have to model the data using machine learning. So it is interdependent on different terminologies or different fields. Okay, coming to the life cycle of data science, we have already discussed with respect to an analogy. Let us give some technical stuffs to the life cycle of data science. First and foremost thing is we need a problem statement. So with respect to that, a clear or a well-defined problem statement has to be identified. And why do we go with data science? We have so many problems which has to be solved. And with respect to business, we are highlighting it wherein creating a business problem. So with respect to the first stage, the important thing is you need to identify a specific problem and it has to be clearly defined. There should not be any ambiguity in the problem statement. Next, it gets followed by data collection. So we are very familiar now wherein data is the first important thing. It has to be collected and it can be from various sources. You can gather the data from any different sources. Next, once we get the data, we cannot start working on it. It has to be analyzed or it has to be cleaned. We refer to that process as data preparation. You clean and pre-process the data. What exactly this process involves? You handle the missing values, you handle the duplication of values. All this has to be taken care in data preparation process. Once the data is ready, next thing is you should have a clear understanding of the data. How do I understand? If I see thousands of millions of data or some numerical values, just assume, can we understand anything out of it just by looking at it? You see hundreds of values or thousands of values. It doesn't give any high impact on if you just look at the data. So we'll try to create a visual representation for the data which is available. So we'll be exploring visually whatever data is available. Once you get the clarity or the visual understanding of what exactly a data is or how exactly it is related, we'll try to model it. And for this particular process or this particular phase of data science, machine learning comes into picture. Data modeling means we need a model wherein you will pass your data to that particular model. With respect to this, we have to select an appropriate machine learning model. And you have to deploy that model in real-time environment, either on web server or mobile app or desktop application. So basically, in this particular stage, you need a machine learning model which can handle your data, or you can train the data on your specific machine learning model. And finally, you have to deploy it in any of the real world environment. Either you can deploy it on the web server or a mobile app or on the desktop application. Finally, once everything is done, we can't leave it as it is. Your model is capable of learning from the data, or it has been trained, it is deployed somewhere. Now we will start testing the model. Once you start testing the model, you should track the model's performance. That is taken care in the monitoring and maintenance stage. And it is very essential to track the performance because it has to provide the accurate results over time. As and when the data or the testing data that is getting passed to the model, its performance has to be continuously monitored to check whether it is giving you the accurate results or not, and it has to be maintained. Now basically everything is fine so far. What did we understand? I understood thoroughly what exactly is a data science. The main thing what we understood so far is I need a data and I'll start working on it. One more terminology is machine learning. So I'll use some machine learning models, it will get trained, and then finally you are getting the output. Now, from where exactly the need for data science arose? Why do we need data science? First of all, everything started through one need wherein we have abundant data. The need for data science, everything started because of the availability of data. We have large amount of data wherein it is going to reveal some important information through the data. That is what we have realized. We can use data and we can get very important information out of the data. If this can be extracted from the data, how do I do that? It is through data science. So basically, how exactly this data science came into existence or how it is booming, it is because we have large amount of data available with us. Let us play with the data. Depending on the need, let us try to extract the required information out of the data which is available. So we live in an era of data abundance where vast amounts of data are generated and collected from various sources, either through internet or sensors or digital devices. From all these different sources, we can gather data. And it is very essential because either you consider an individual or an organization, data is very important. Through the data, what they will do, they'll be trying to decide on something. So it acts as a data driven decisions. You will take some decisions based on the data which is available. And what happens through this? Some hidden insights you can reveal. Nothing will be clearly visible just by looking at the data. You should extract the hidden insights out of the data which is available. That is the job of a data scientist. And it is used for solving complex problems across various domains. Since machine learning is also into it, we will always try to solve some complex problems through ML approach. And nowadays it has become a critical tool for innovation and efficiency because it addresses different challenges of data driven world. So basic important thing is we have abundant data, and the more you work on the data, it reveals more insights and you can solve complex problems because even ML is coming into picture, and you can solve innovative problems. You can develop innovative tools wherein the efficiency will be increased. Now, how this data science is changing the world? We have some problem statement, we have the data, explore the data, finally apply some ML model, test the data, and finally you will get some accurate results. How is it changing the world? How exactly, where is it applied? It is applied everywhere in almost all the industries. Data science is reshaping the world across all industries. You consider healthcare, even there it is applicable, wherein you can diagnose different diseases and you can propose a personalized treatment. Everything is through the data that is available based on the disease diagnosis specific to a person. Consider the same with respect to different businesses. So each and every business has their own limitations and their own need. Collect the data. Depending on their need, you optimize the operations. Try to automate the process so that the cost will be reduced and you can also improve the efficiency. Consider any of the financial services. So with respect to financial services, you will be dealing with risk assessment and there will be so many fraud and thefts. So it has to be detected, and this can be achieved by utilizing the data which is already available. So this plays a major role in financial services. Next, consider the smart cities. Everything is getting automated now. So using the data for urban planning and also resource allocation, so that you can plan for smart cities. And coming to weather forecasting or climate and environment, you can monitor each and every parameter. Each and every parameter is acting as a data here. And coming to the education field, everything is available. You have lots of data, but you want to fine tune the available data. So you will look for a personalized learning. Even though I have lots of information available, but I need only a specific information. So you can personalize the learning, and through that the outcome can be improved. And also coming to the transportation, it is the need of the hour wherein we'll always talk about autonomous vehicles and traffic management, a big headache. Try to automate the process. Is it possible? Is it complex? Yes. If it is complex, it becomes challenging. Yes. If it is challenging, we'll try to solve it. That is how the world is going on. Then coming to the agriculture aspect of it, even this revolution is happening with respect to agriculture, wherein you are trying to optimize the crop yield. You will automate the process of disease detection. You will automate the process of applying pesticides or avoiding pesticides. In which stage, what, each and every data can be automated. And also in food supply chains. This is how drastically data science is changing the world. Okay, now we understood thoroughly how exactly data science is playing a major role in our day-to-day life in different fields and domains. So keeping all these things in mind, can we relate it to a term called projects? What are the different types of data science projects that are carried out? So with respect to that, we have four different terminologies. Firstly, we call something called as a descriptive analytics. So coming to descriptive analytics, you have the data available. What you will do with the data? You will start analyzing the data. If I have the data from Jan 23 to October 2023, it is treated as a past data from Jan to October 27th. Assume that excluding today's. So it is acting as an past data, and I'm trying to understand what happened with respect to this. From Jan till October, what is the variation? What is the gain? What is the loss? For example, if you consider sales with respect to a particular product, each and every month I'll try to obtain a report. Sales history, what is the profit, what is the loss, what is the drawback, what is the comment, positive, negative. So we have so many different parameters to be considered with respect to a particular sale business that we are considering. So each and every month sales report has to be analyzed. And this analysis is with respect to the past data, and it is treated as descriptive analytics. And one more type would be diagnostic analytics. You have analyzed. You will dig deep. Sometimes you have got profit, sometimes you have undergone loss. Why there is a sales drop in March? You will try to dig more information wherein you will collect more information from, I mean, towards the month March. Are there any festivals or not? Even though there are festivals, the sales has been dropped. What was the reason? uh, is it related to the customer satisfaction? Is it related to the default in the product? There are so many factors which leads to drop in sales drop in March, but it is not the same case in April. So what was the relationship between the sales drop in March and April? So these things can be analyzed by digging deep into the data, whatever has been analyzed, and you have to specifically see what has gone wrong and how to overcome that, keeping that in mind. And say, even though you have the data available, once the analysis is done, past is fine. So I have analyzed everything. By analyzing the past data, there is a provision, or it can be used to predict the future data also. That comes under the category of predictive analytics, wherein you will think about the future trends or the occurrences, and all these are possible based on the historical data. Last year, what has happened, use it as your input. Analyze the data rigorously, monitor it, try to predict it for the next year. Whether that prediction is accurate or not is fine, but you can predict based on the historical data. It means that future occurrences can be predicted. That comes under predictive analytics. So you can predict the next month's sale based on previous month's sale or based on last year's same month sale. There are different factors which you can use it to predict the future trends. Next, coming to one more type, which is nothing but prescriptive analytics. Once you predict, you can offer the recommendations. You have analyzed the data thoroughly and you can offer a solution. You can recommend something. To boost the sales next month, include this offer. You have the historical data. That is what you have done last year. Even this year, you do the same thing, but increase the number of percentage so that the sales will boost next month. So these kind of recommendations can be done based on the available data, based on the past history or the historical data, whichever is available. So depending on the need, either you will analyze only the past data and keep it and maintain the report. That can be used by one more process, wherein they will dig deep into the specific outcome to highlight what is wrong, what is positive in that. And then you can offer recommendations. So these things fall into 4 different categories. Okay, now we understood what all can be done. How all these things can be done? How do we do it? So tools and technologies comes into picture. What are the tools that are available, or what are the tools that are used in data science? The first and foremost important thing would be your programming languages. Which programming language is best suited for data science? I want to learn data science. Which programming language shall I choose? Shall I choose C, C++, Java, Python, R? Which are the programming languages I should go for if I have to become a data scientist? The widely used programming language would be Python. Even R was quite popular before, but Python has occupied everything and it is widely used by almost all the industries for that particular task. So Python is the widely used programming language. Okay. Now, what is the other tool? Programming language is fine. Okay, let us learn Python and let us start working with the data science projects. What about the visualization and reporting? Since you have the data, I have to report, I have to visualize the data. For this, we have certain tools available or the libraries. We have something called as matplotlib. It is a very huge library available in Python for visualization. Similarly, you have Tableau and Power BI. Matplotlib is purely programmable thing, wherein if your fundamentals are strong in Python, you can learn Matplotlib. You can start using it. The modules available in this particular library. Tableau is non-program based. And Power BI for business analytics visualization will be going with Power BI. In today's session, we'll have a quick tour with respect to the Python programming language, followed by the Matplotlib. And the next thing would be your machine learning frameworks. There are so many frameworks available. Either you will go with the TensorFlow or you will go with scikit-learn. It all depends on the problem statement. Whether you dig deep or you have complex problem statements, what kind of data that you are dealing with. Either you are going with the ML approach or you are going with the deep learning approach. All these things are dependent on which particular libraries. I mean, depending on the problem statement, you will select which framework to be used. Next, how do I maintain all this data? We have big data platforms. Basically, you will store and process and analyze the large volumes of data. And this can be done either by using a technology called Hadoop or Spark. And also one more thing is which particular database system you are maintaining to handle this large volume of data, either SQL or NoSQL. And coming to the cloud platforms, how exactly you will store this data? It is with respect to beyond the big data platforms, we'll consider the infrastructure along with AI, IoT. Which one will offer these services? Either you will go with AWS or Azure. So these are the different tools and technologies that we should be aware of whenever we are into data science. Okay, now I have thoroughly understood the process and few terminologies, and I'm eagerly waiting to learn data science. How do I start? I'm a beginner. I should start from scratch. I need to know what has to be done. I'm ready to do it. What do I need? Firstly, you have to start learning Python. That is the basic thing. You should be familiar with any one of the programming languages, and the best thing you can start with is learn Python. Is that alone enough? If I know Python, can I become a data scientist? Along with that, there are few more add-ons. You should have a very basic fundamental knowledge about statistics and maths. It is not something very different. You need to know integration, calculus, or differentiation, something like that. You need not recall all those things. Basic fundamentals of statistics and maths concepts are enough. Next, you should also learn about how do I analyze the data using Python. Once you know Python, there are few libraries which you have to learn. Through that, you can do the data analysis. Once your analysis is done, next thing would be your machine learning concept, which will be coming into picture. So in this session or today's session, we'll be throwing light on all these parameters wherein Python basic things which are needed for today's session. We'll have a quick brush up on that. And then basic fundamentals on statistics, mean, median, variance, something like that. Those basic fundamental things we'll be working on. Then how do you analyze the data? We'll come across different libraries, NumPy and Panda. And basic fundamental concepts or the terminologies what we have to know in machine learning. So that will be taken care in today's session. Okay, so I am equipped with the sequence in what I have to start learning. First will be your Python, followed by data analysis and the machine learning fundamentals. Okay, now I am ready to start learning. How do I learn? Where do I start? The first thing would be you should start understanding the types of the data. How many different types of data are there? I am dealing with data. And it is not that I have only one type of data, I'll have different types of data. So I should have a clarity or clear understanding on different types of data. And I'll be exploring or I'll be analyzing the data through data cleaning techniques. Once I analyze, I'll try to give a visualized approach through an exploratory data analysis. Now, once I am thorough with or I am ready with the data, I will always look for the features in the data. From the available feature, can I generate a new feature? So that can be handled using feature engineering. I have 10 features. Out of the 10 features, you analyze the data and try to extract a new feature out of it. That is possible through feature engineering. Now coming to statistical analysis, you have the data, you calculate the average or the mean or the median, try to establish the relationship between the data that is available through the statistical analysis. Once it is done, you train the model. How do you do it? Using machine learning algorithms. Now through this, you will be able to predict based on the new data given. Once your model has been trained, start giving the inputs to the model. They are all new data. And for that, your model should accurately predict the output. And once it is doing this, you visually check how much accurate it is. Which model is giving what accuracy. So that I'll get a clear picture how my data is behaving and how my model is capable of predicting the output. So this is the quick overview or the terminologies what we come across in data science. Now coming to learning different types of data. Firstly, consider you have numerical data. So this numerical data, it is not 10 numbers or 10 values that you are representing, thousands of millions of data that you are representing. In such cases, you cannot simply create you can't simply type 10 data or 100 data. I will maintain a file to save all those data. I'll call it as a CSV data, comma separated value. It is a specific file which is holding the data set. You have thousands of values or millions of values. That is what has been highlighted. This table represents your data set. And what is this? It is the data related to a book. What is it all about? You have the product ID. It means that the ID given to a specific book. And what is the title of the book? And what is the review given? And an ID has been generated for each and every review. If it is a very good feedback, rating is also given. So with respect to this, a data set has been prepared. Now this data is available. What do I do with this data? I have a problem. Now, what is that problem? I have to identify all the highest ratings review. So from the available data, what is my job? I'm not telling you how exactly to do it, but what exactly is the need of the R, I'm just telling you, wherein I have to highlight the highest rating reviews. Can I do it or not? Manually, how will I do it? I'll go to each and every row, check the highest rating is 5. So wherever the rating is 5, in the last column, I'll check the entire row. I'll use it or I'll copy paste. Again, check wherever there is 5, copy the entire row. Wherever there is 5, copy the entire row. Manually, this is what I'll do. You automate the same process. If there are 10 values, if you do, it is fine. If there are 100 values, if you do, it is fine. What if you have millions of values? Will you sit and do? Let us try to automate this process wherein I have a requirement. I have a clarity with the data. First of all, I need the data. I have the data. Do you have a clear understanding of the problem statement? Yes, I have a problem statement understanding. Whenever the star rating is 5, consider the review or the product title so that that product has high importance, that has high value. This is how I am giving a meaningful insight into the available data. And that is useful to me. Whichever product has highest rating, I'll buy more, which means that it has more intake kind of a thing, which will be sold fast selling. So I can conclude like this. So this is one type of example wherein you can work with different types of data, a numeric data, star rating, whatever numbers you are specifying, the numeric data, based on that you will extract the entire row data. Next, coming to the textual data. Now, whenever you come to the textual data, you have a separate domain itself to deal with it, which is nothing but your natural language processing, NLP. So with respect to this, consider a one more data set wherein previously we concentrated more on the numeric data, which was the star rating. We concentrated more on the star rating. Now we are concentrating on a textual data in the same data set. So what is the textual data? I have to identify the positive and negative comments. Each and everybody will write a review for the products that they buy. They are all your textual data. So from the textual data, you should be able to see the positive words in the statement. If you find any positive data, positive comments, you treat it as positive. Whenever there is a negative remark, you treat it as negative. Highlight those things. Categorize those things. Based on what? Based on the content that is there in the review. It means that each and every word that you see will convey a meaning. Using natural language processing, we will try to highlight it as a positive comment or a negative comment. Why do I have to segregate like this? Why do I need positive and negative comment? I want to correct the mistakes. If there is a negative comment, let me try to correct it. If I have a positive comment, let me try to explore more towards it. Let me try to maintain the same positiveness. So here I am trying to deal with the textual data. Now coming to one more type of data, image data, wherein they are not structured, they are all unstructured data, and the type of the image can be your JPEG or PNG or BMP or whatever it is, the different formats that you are representing. Basically, it is an array of pixels data, which are in different formats. In this, what requirement do I have? A basic requirement would be you have a need to classify different types of animals or something like that, wherein in this particular data set of images you have two different types. You have dogs as well as cats. I have a requirement to classify only dogs. So I am dealing with what type of data here? It is image data. At the same time, we'll also come across one more different type of inputs, which is nothing but a video data. I'll give you video as an input. Video is basically nothing but frames played at a specific frame rate. So out of this video, what am I supposed to do? I have a video, detect the objects. I have hundreds of objects in the video. You can just have a look at this video. What is it highlighting? Basically the different objects. Name of the objects. Your machine learning model has been trained with numerous images of the same objects. A chair, a laptop, a TV, a bottle, a person, a book. These are the different objects the machine learning model has already been trained. Once you give this new video as an input, each and every frames are taken as an input by your model, and from each and every image, it is trying to extract an object, and that object is matched with the model which has been trained. And the model is accuracy is highlighted over here, wherein it is predicting this object as chair, and the accuracy obtained from that model is 99%. It is detecting a laptop, and the accuracy that it is saying is 70%. A TV, a bottle. So this is the accuracy with respect to the model which is giving for each and every object that it is able to detect. So these are the basic different types of data that we usually work on. So now we are clear with the different types of data. Now, what exactly are we supposed to move on to the next stage? From data, it has to be data cleaning techniques. What do we do here? We'll take care of certain aspects wherein you have to handle the duplicates. If there is any inconsistencies in the data, you have to handle. You have to correct the errors. You have to deal with the missing values. If some values are missing, how do I consider? Should I throw the entire data set, or can I still work on the data set by doing some manipulations or by applying some data cleaning techniques? So this comes under data cleaning. Now consider this. this basically, whatever data is highlighted in the table, we call it as a raw data. And what does it contain? Different features. Which are what are the features? You have a review ID, you have a product ID, customer ID, review text, rating, and the dates are mentioned. Basically, this is the data set of products and services based on the customer feedback. You are analyzing the customer basically, and this data set is useful for that. And what are the issues in this particular data set? I have the data set available, that is fine, but there will be some issues. First thing would be incomplete data. When you will say that the data is incomplete, some data will be missing. In the sixth row or the review ID 6, you can see that the date is missing. Any are not applicable. Got my point? So in row 7, customer ID is missing. Got my point? And also one more type of issues would be the data length. Data length, you can't fix. It has to be 10 characters. It has to be 5 characters. It has to be 100 characters. It can be of variable length, but still you should be able to work on it. Sometimes it can be very lengthy. Sometimes it can be very small, or it can include some extra spaces, or it can have some punctuation marks. Either is it useful or is it worthless? You can decide and work on it. Next thing would be date format. Date acts as a very important feature. I have to track the date. Based on that, the products will be evaluated, or I'll get more insights into the specific product. What if the data format itself is inconsistent? What do you mean by that inconsistent data format? It is with respect to the order in which you represent the date. Either it is year, month, day, or how many characters you represent in year. Let us follow some consistent format. And then one more case or issue would be mixed cases. You can have a combination of uppercase letter as well as lowercase letters. Does it lead to any problem? Even if it leads to a problem, you solve it. Either you make it all uppercase, either you make it all lowercase, or you make the beginning letter as uppercase. You should make use of the available data. If you come across with any of the issues, try to resolve it and go ahead. So that is what your data cleaning is all about. Now, how do you handle the missing data? How can we handle? If it is possible to extract from the previous data, it is fine. Otherwise, if it is not possible, we'll try to remove the entire row. If the customer ID itself is missing, how can I get the data? If the date is one of the important factor, if it is missing, how do I make use of that data? It doesn't give any valuable information at all. In such cases, we'll try to ignore or remove the particular rows from the data set. Now, one more thing would be you have extra spaces or you have too lengthy sentences, something like that. How do you standardize? From this particular table, you can have a look at it wherein all extra characters are removed and everything are aligned towards the left. And this kind of strategy you can run on any of the text data set wherein you cannot directly remove all the content. What is needed, you retain. What is not needed, you can exclude. And that is how you are standardizing the text. What to do if I have an inconsistent date format? Check with the fourth row wherein the date is inconsistent. All other rows have year followed by month and the date. Now here it has a different format wherein you have the date first followed by month and year. Now this can be altered. So in such cases, you will not remove the entire row. You will try to reframe or format the desired date content. So it has been done. If you have mixed cases with respect to uppercase and lowercase letters, convert all into lowercase letters. That solves the problem. If at all you have a issue with that, change it, wherein your data will be retained as it is. So basically what exactly happens, data cleaning means it involves identifying and correcting the errors. For what? If there are any inconsistencies in the data set, you should make sure that the data is accurate first. Only then if you analyze the data, you can get insights into it. You can extract more information out of the available data. So what we have done so far, we have handled the missing values, we have standardized the text. If there is any inconsistencies in the date formats, you alter it and you convert the text cases. So basically you need a data set which is clean and it is ready for analysis. That is what is the main outcome of this. We should get a clean data set which should be ready for analysis. Is that fine? So with respect to this, data analysis is done. What is this exploratory data analysis? I have the data. Data collection itself is a big headache. I have collected the data. After collecting, I have analyzed the data. Analysis in the sense, for example, you just think you have cleaned the data, which is ready for analyzing. Now, what you have to analyze for? I have the data. This analysis is referring to identifying the relationship between the data. Your data is ready, but you have to analyze it for establishing the hidden patterns or establish the relationship between the data so that you will reveal the hidden patterns in the data. And this is done using exploratory data analysis. Establishing the relationship between the data helps in revealing the hidden patterns. And this process is called as exploratory data analysis. And this is achieved, this exploratory data analysis is achieved through visualization. What is this visualization? How exactly data is related is visually represented through charts. You can plot different types of charts. And they are named as histograms or scatter plots or box plots. So basically, whenever you consider a data, you will apply statistical measures to it. What is that? You calculate the average or the mean or the median so that you will get to know the relationship between the data. How far is a particular data point or how near is the data point? Through this, you will get some key insights into the data, and this will help in the further analysis. So basically, if you have a data like this, you will try to analyze it by considering different types. What is that? Age, it is a numeric data, and gender you have. All these are categorical data. Product purchase amount is numeric. And what is the summary of the statistics that you will be applying? You will calculate mean, median, standard deviation, and how age is related, and what age group is interested in what. And you can also deal with handling the missing values. And these things are visually represented by plotting a graph. If you're dealing with only one type of column or one feature, only for age, if you plot a graph to check the age distribution, how many different age groups are considered for this particular analysis. And what is the purchase amount? Can you categorize the purchase amount? Is it all above thousands or is it all below hundreds? So that, and what is the outlier? How many very different purchase amount are highlighted in this particular transaction or for the particular day? So these things can be visually represented by using either one column or individual column, or we can also consider two different columns. So that is how visually you will represent the analyzed data. Next would be one more important aspect of data science would be feature engineering. Basically, it is the process of creating new meaningful features. From what? From the existing data. So it means that data is available. From the available data, can you create a new data? Is it possible? And to do that, we'll use different techniques. They are called as one-hot encoding, feature scaling, dimensionality reduction. And it is not that always you have to create a new data. If there is any redundant information, you can also reduce the number of features. And all these things will be taken care using feature engineering. Only after that, you will be passing the data to a specific model and out of which you will get some insights. Now consider this data set wherein this data set deals with credit card fraud detection. To detect a fraud with respect to credit card, you cannot directly say yes, it has happened. You need some data to claim that a fraud has happened, a theft has happened. So with respect to that, we will try to add features like time of transaction, what is the transaction amount, and what type of transaction, is it online or offline, or what is it, retail or grocery, what type of transaction is it, and the customer location, merchant location. So all these are the important factor which we take into consideration to say that there is a credit card fraud detection, it has happened. And out of all this, I need something wherein transaction frequency has to be estimated. I want to highlight how many transactions are done from morning, the duration from 9 to 12, from 12 to 5, 5 to 10, and 12 to morning. So like this, I want to know the transaction frequency. So this transaction frequency is acting as an additional feature. That feature is not there in the data set, but I can generate this feature out of the available data. I'll do something, but can I not get this transaction frequency? How many transactions are done from the morning? Have a look at the table over here. How many transactions are done in the morning? From the second column, time of transaction, how many morning is highlighted? 1, 2. So 2 transactions. For this particular data set, I can say the transaction frequency for morning would be 2. From the same available data, I can say for afternoon, how many? 1, 2. So like this. Then I can also have one more feature which can be generated out of which is historical transaction patterns. This you can get from the past transaction history. And if you have the past data, you can calculate the average transaction amount for a particular month or for a particular year. And you can also calculate the standard deviation. They're all your statistical measures. And you can also get one more feature, which is the geographic deviation. Is the merchant and customer in the same location the transaction has happened, or the customer is in different location and the merchant is in different location? And if it is a retail thing, if it is not online, how is it possible? Based on the location. So the geographic deviation can also be one of the important feature which can be generated from the available features. Through all this, you would be able to say it is fraudulent, yes or no, based on the fraud detection. Absolutely, there is no chance that this can be a fraud. And absolutely, you can say that it is a theft or there is a fraud detection in this particular scenario. So this is what can be highlighted by generating new features from the available features in the given data set. Once you are done with the feature engineering, what next? The statistical analysis. What is the statistical analysis? Basically, it deals with the basic terminologies: average, mean, variance, standard deviation. You will sample the size, you will do the regression of it, the numerical values. And how do you do it? You have different data set. Consider whichever parameters you are interested in or the features. You start calculating the sales data. So sales from the available data set, each and every data has been highlighted. You calculate mean of it. It represents the sales performance. So you're doing sales performance analysis by considering only one feature and by calculating the mean of it. So similarly, you can do it for product category, sales, market expenses, and the customer age group. If you want to highlight, you want to generalize what is the age group. It is neither less of this nor greater than this, and the gender also. So like this, you can analyze based on the data available. And how much it is deviating with respect to the available data. You can calculate the standard deviation. So these are some of the statistical measures that you can consider and try to establish the relationship between the data. Based on that, wherein you can take some actions or act accordingly. So till now we have dealt with collecting data, analyzing data, handling data, visualizing data, exploring data, everything is fine. Now data part is done. I should start working on the data now. How do I do it? Now we'll get into a field or a domain which is nothing but machine learning. What is it? Your machine should learn the data. Make the machine to learn the data, and it is one of the essential tool for a data scientist. Through this, what is the advantage? It enables an automated analysis of large data sets. You need not sit and learn. You are trying to automate the process. How do you are trying to automate the process? By training the model. You are giving all the data to the machine learning model, wherein your model should get trained. And it is a large data set that you are dealing with. So it helps in automated analysis and the extraction of valuable insights and predictions. Now, what is the data scientist role here? He'll combine the domain expertise with ML techniques, and it helps in solving complex problems across a wide range of industries. So with respect to this, we'll come across different types of machine learning. What are those? I'll just highlight the names of it. We'll discuss in detail after a few minutes. Different types of machine learning would be supervised learning, unsupervised learning, or reinforcement learning. So these are the three different types of machine learning models that we will come across. Now to understand this process, we will come across, let us understand with an analogy. What is that analogy? Wherein we are trying to consider a musical DJ. What is it all about? Imagine that you are in a DJ party, a music party. What do we expect from a music party? A perfect song for the party. It should be very apt. Each and every song you should feel that it is the must song which has to be played. And your job is to play a perfect song for the audience at any given moment. The song keeps changing, but each and every song should be a perfect song. And important thing is you don't have a predefined playlist over here. And you're not sure which songs will be hits with this particular crowd. Initially, will not be clear at all. There is no predefined playlist, and you are not sure what this crowd will like. So then what we think of is we'll plan for a smart music recommendation. For what? To choose the best songs. Intention is to play the perfect song at any given time. For that, you have to develop a smart music recommendation system. And this system should choose the best songs. So keeping this requirement in mind, let us start the process one by one. What is my data science process? I should start with the data. So who is the party goer? He represents the data. And each and every person has their unique music preferences, and they are treated as data points. And all of them have the different characteristics. So the party goer is treated as a what? He is representing the data. He is treated as a data point. Now, what am I supposed to do? I have to develop a recommendation system or a model. It means that I have to develop a machine learning model. And what it has to do, it has to suggest songs based on the current mood and the time of the day. And all these things is based on the response of the party goers. So it is all predictions based on the data. So if I have to develop this model, I have to learn something. This model has to learn something. And how is it possible to learn? How the DJ is able to play based on the crowd reaction. That is how a DJ learns. How exactly they interact or react. So similarly, our machine learning model has to learn from the interaction. So as the DJ, you don't know in advance which song will be hit or flop with this particular crowd. But you will learn, you will improvise through the interactions. You will play the song, you will observe the audience reaction. and accordingly you will rephrase the list or you will adjust the choices depending on the responses. The same learning process is suitable for your machine learning models. They will learn from the data, provide more and more data, and refine it, do the fine tuning. That is how it learns best. Here you will learn through interactions and feedback. There also you have a feedback system through which you will make the learn model. You will make the model to learn better. And once it is done, you have started learning from the interactions. What you will try to do, you will try to generalize. You will start to notice the pattern. So this is what this tempo is required, this volume is required, this type of music is required. So that you will start, that is treated as a pattern over here. You will try to notice that pattern because you have played hundreds of songs and the 101 song you want to play, it falls under this pattern only. That is how you will select the next song. This kind of learning should be given to your machine learning models. For example, you realize that the crowd, they tends to enjoy the rock music more and they need some steps to dance. As the night progresses, they give more preference to dance. So in that case, you have to change the pattern. So this ability of generalizing from past interactions to how machine learning models generalize is all based on the data that has been trained, and you have to make predictions on the new unseen data. Whenever a new data comes, you should use the knowledge of the previous data and you have to handle the situation with respect to a new data which has come. Then finally, I have to optimize it. As the party continues, you have to fine tune your song selections, you have to adjust the tempo, and you have to keep the session, I mean the party live. So this deals with different parameters that you consider for fine tuning. And how do you optimize your model? Basically to improve the performance. So whatever we are dealing with this particular analogy, what is the process that has involved? The same thing applies to your machine learning model. And finally, once everything is done, optimized, it has to be automated. A quick response should be there for each and every situation, and it should play automatically. You have to deploy the trained machine learning model in the real world application, and automatically you make the predictions, you give recommendations, you start playing. So this process should be automated using machine learning models. So how do you do it? Either it is a music party or a machine learning model. A feedback is essential. I like this song. Please continue. That is what is a feedback. Either it is a party or a machine learning. Initially, you will train. Until you are trained, you will be accepting feedback. Through that, you will learn. The model will also learn. And once a new data starts coming based on the trained data, it starts acting automatically by adjusting the predictions based on the feedbacks which was already received. So this is the entire process we follow with any of the machine learning models. So once the model has learned, or once the model has been built, it has been trained thoroughly. You have to predict, right? Whenever a new data comes, the model has finished training. It has learned through feedbacks or large amount of data. So the training is completely done. Then what happens? You should start predicting. So building the predictive model is one of the core aspect of data science. Firstly, what you will try to do, you will train the model. Once the model is trained, you should check for its accuracy. You should validate the model. You should estimate how accurately it is working. And then you will try to optimize the model. And to optimize, you will either use hyperparameter tuning or you will do cross validation, how to estimate all these things. Finally, you have to measure the performance of the model and make accurate predictions on unseen data. Whenever a new data comes in, an accurate prediction should be done. And where is it applicable? Where exactly you can come across this predictive modeling use cases is basic thing would be your weather forecasting. You can predict the future weathercast based on what? Based on the past history and the current weather data. Current weather data, it can consider different parameters like wind speed, humidity, temperature, and all these different parameters, and you can predict the weather. One more thing will be in your online shopping. This is very common, wherein you will be recommended with lots of products. If you're shopping for a clothing, it will also recommend you to shop for a footwear, because it is recommending based on the input or your survey or the model which has been trained. All the associated products along with this will be recommended, or it will be predicted. You need not ask for a footwear. When you are going with the clothing, automatically it will try to suggest you with the watch or footwear, something like that. And also, if you want to visit any of the places, if you are thinking of one particular temple or something like that, all related temples nearby will be recommended. That is nothing but your prediction system. So once all these things are done, so what exactly is the next one? Finally, the accuracy of the model or the performance of the model should also be visually seen. How exactly the system is behaving or the model is behaving. And you have to communicate this to others. And it is through data visualization. And it is done using visualization tools. Either you use Matplotlib or Tableau. Basically, you are representing the performance of the model using visualization tools. And these are different ways in which you can represent a visualization chart. For different applications, you will be using different charts. So if it is a customer behavior, you can consider what is the amount of time spent, how many pages he has viewed, or what is the purchase amount for a specific customer. So graphically, you are representing the data set. So visual information gives you more insights than looking at the data set. And you can establish the relationship also once you have a visual representation. And with respect to social media, you can plot a graph and you can see how many likes are there for this particular post. For each and every post, you can check which post has the highest likes or highest comments, or which post has been shared more. So visually you can analyze these things. So keeping all these things in mind, we got some clarity. What exactly is data science all about? How exactly a machine learning model works? What is it all about? Can we relate this to our every day-to-day analogies? So that is how we think. What is the data scientist role in day-to-day life? For example, you consider data science as a chef. What exactly he is supposed to do? Chef will be in a restaurant, and what he'll do, he'll try to gather various ingredients. Basically, he has to prepare some dish. He'll collect various ingredients. They are treated as data. And once he receives the data or the ingredients, he'll try to clean and prepare them. So he's doing the pre-processing part. Even data scientist will do the same thing. And chef will always try to explore new recipes. So he has to experiment. What data scientist will do, he will experiment with the models and algorithms. And finally, what this chef should do, he should give me a delicious dish. So that is what your machine learning model is also supposed to do. It has to predict accurately, and it has to give the accurate results to the end user. That is what a chef do to the customers. So this is with respect to treating data science as a chef. Now consider data science as a gardener. What a gardener will do, he will cultivate and nurture the plants. For that, what he needs the right conditions. What conditions? He need a very good seed or a plant. Then he need good environment or the temperature for growth. And they carefully select those things. Even data scientist has to carefully monitor the data. And what a gardener will do, he will continuously monitor how the data is progressing or how the plant is growing. In the same way, data scientist should carefully monitor the progress. He should harvest valuable fruits. Here, You have to give or come up with an accurate model which can predict the results accurately. Similarly, when you come across a financial advisor, data is very important. Based on that only, he will suggest you for an investment recommendation. So your historical trends is the major thing. For data is an asset here. Even for data scientist, data is an asset. Even for financial advisor, that is what he is doing. Then he will start building different investment strategies based on the historical data. So that is what is done using machine learning models. And finally, he'll guide them. Take this decision for a better future financial conditions. So that is how we give insights to the customer through the machine learning models. Now we are very clear with day-to-day requirement for a data scientist and how exactly we are trying to deal with the concept of data science. So the journey of becoming a data scientist is a quite challenge, and it is a rewarding path. What do you need for that? You need the right skills. You should acquire a right skill. I have an intention to become a good data scientist. I need a very good career path in this. What do I need? I need the right skills at the right time. And I should also build a portfolio. I should build my portfolio should be very strong, and I should have very good networking, and I should be updated. I should keep myself updated. Through this, you can enter into the exciting field of data science. Different designations related to this would be basically you can start as an intern, or they may call you as a data analyst. And once you get exposure towards analyzing the data as an intern, you will be promoted to a coordinator analyst. And there you can be put into either marketing or financial or something like that. From there, you will go to the next stage wherein you will become a senior level data scientist, wherein you should deal with the database admin, wherein that big data thing comes into picture. You have to handle large amounts of data. Next, you will go to the manager level, wherein all different subdivisions will be under your control. What are those things? The different stages, whatever we have come across in the data science process, the same thing. You should have a clear, thorough understanding of each and every stage that is happening in the data science. Next, you will go to the director level, vice president, and chief data scientist. These are the designations that are highlighted with respect to data science career path. I have highlighted few of the responsibilities and skills with respect to a specific job role. Data analyst would be dealing with cleaning the data, organizing the data, and basic analysis he'll be performing. He'll be generating the reports and dashboards. And what are the skills he needs for this? He needs basic cleaning and wrangling skills through the data, through the libraries which are available. He can do it. And he also needs to handle with the tools like Excel or SQL, the databases, and he should also represent the data visually. So he need exposure towards data visualization libraries and the basic statistical knowledge. So this is the important skill towards a data scientist. If you are becoming a business analyst, you have an extra responsibility wherein you have to collaborate with the stakeholders, business stakeholders, wherein you have to define the data requirements, get the data. So you need to have a very good understanding with the business stakeholders, and then you have to transform the questions into data analysis tasks. See, whatever a business stakeholder gives you as a problem statement, it can't be directly applied. It has to be translated to your data analysis task, and then you can take some data driven actions or decisions. So what is needed for a business analyst? You need a strong communication and problem solving skills, and how to translate from business requirements to your data driven requirements. That understanding you should have, and you should know data analysis and visualization. Next, what about this data scientist? This is where the exact need comes into picture. You should have a very good strong insights on machine learning models. You should be able to develop a model and apply the model, which model suits for what. Basically, you have to extract large insights from the data using machine learning models. And you should predict the solutions. This is the main role of a data scientist. And what are the skills that is required? You need to know programming very well. Either you are strong with Python or R. Now, Python is everywhere, so assume Python you are strong. Then you need to learn machine learning, statistical modeling, and the data visualizations expertise. Finally, you need to know the ML libraries. To deal with machine learning models, you need to know TensorFlow or scikit-learn, or whichever IDE you use. You work on Jupyter or Google Colab, or you use PyCharm, or whatever it is. You should have some strong skills in any of the platforms. That is the job of a data scientist. Next comes the role of a machine learning engineer. He himself has to implement new machine learning algorithms. He should be capable of developing a model. He should build and deploy it at the production level, so that he'll be able to, or the new model which has been developed will be optimal and it gives optimal performance, and it should be scalable also. So what are the skills required for this? Advanced programming, Python, Java or others, and deep understanding of machine learning algorithms and libraries. And you have to deploy it in specific environment. Finally, you will be the data science manager. You should be able to manage each and every team of a data scientist and analyst, wherein you have to define the project goals and strategies, and you have to communicate the results insights to non-technical stakeholders. So you should have very good communication skills here. And you should also have the project management skills. You have to lead with each and every team, and consolidated output has to be obtained in time. And you should have a very strong fundamentals or the understanding of data science methodologies. And within the teamwork, there should be effective communication. So that has to be taken care by the data science manager. So with all these different roles, what exactly specifically data scientist work on? He works on different projects related to cleaning up the data, different projects involving EDA, and different projects involving data visualization and machine learning. So these are the 4 important types of projects a data scientist will majorly work on. So with all this understanding, I'm ready, or I have got some insights into the concept of data science. But keep one thing in mind, it is not just a job. Data science is not just a job, it is a journey wherein you should continuously explore. You should be continuously updated so that you will discover some new things. It has vast potential for innovation. Whatever challenging tasks you come across, you can innovate something new. And it has a great impact on the industries. And due to this capability, there is an exciting career path for data science aspirants. If you have passion for data, if you have passion for problem solving, if you have enough required skills, you have an exciting career path. So what is that you should focus on? You always need to stay curious. You keep learning so that you will get into the world of data science to do wonders. So this covers the entire introduction towards the data science concept. Are you guys with me?
Yes. Yes, we are. Yes.
Okay, so as of now, the first agenda for today's session was to give an introduction towards the data science domain. Hope it has reached all of you. So the next thing what I would like to continue is
Yes, ma'am.
with quick tour towards Python programming. Was it fine, Adarsh? Am I too fast or how was it?
No, ma'am, it went very well. I think so. Everyone got the very good insights of data science. I think so. Folks, everyone are ready to like work on the data science with some data sets, and I even shared the drive link in the chat. Please download the prerequisites that are shared by Asharani ma'am. Please download that. And ma'am, I think so. Let us begin with the mainstream of working on data science.
Sure, sir. I'll just start with Python intro. I mean, in the sense like let us quickly rush through that Python concepts.
Yeah.
I just wanted to know, are you people familiar with Google Colab? Any 10 responses would be enough. Can any
Please,
10 of you?
please type one in the chat. Who knows Google Colab? Please type one in the chat.
If you have the same comment as others have commented, you need not type it. If you have anything else apart from what they have typed, or if it is different from that, we just can have a look at it. Google Colab, are you people familiar with that? Because I'll start with Google Colab now. If needed, I can talk on it for 2 minutes. Google Colab, yes or no. If there are more no's, I'll just brush through that. So one yes, I could see. Yes is for Google Colab itself, I think so. Can others also respond?
Guys, please be
There are only
responsive.
two
Okay.
yes. Okay, no, no. Okay, you need not worry about in depth or not. Basically, that Google Colab environment, if you see, it is pretty easier.
So now we are getting so many no's.
Yeah, yeah.
Yeah.
Okay, no issues. If you don't know, that is the best thing. We can learn the best. If we know, even then we can learn. You be with
Yeah.
me. Fine. Okay, okay, no issues. We'll go with this. Okay, basically, what exactly we are trying to do now is,
Ma'am, please give me a minute. So,
yeah.
so guys, in between you will get so much of doubts. Okay, at the end of the meet, you are gonna get the 30 minutes of Q&A session. So in that session, we can discuss the doubts what you got in between the thing, between the session. Okay, I think so. This sounds good, right?
Sir, you
Is that
want me
okay,
to
ma'am?
wind up the session? Others, sir?
Yeah,
I need
tell
your
me.
attention. Others, sir. Yeah. By 12, you want me to wind up so that you will have half an hour Q&A session, is it?
Yeah. By that
Oh,
we can have a Q&A session at the end of the thing. Like so many people will be having some doubts regarding career
oh,
also. So we can
okay,
discuss
okay,
that.
okay, okay, fine, sir. So I'll just rush through see, basically the plan is like this. Now we have understood what exactly is this data science all about. Theoretically, we have understood, and through analogies, it has become very clear. I assume that it is clear. Now, this much is not sufficient. Will this make me a data scientist? No. Something more than this is required. What is that? I need to code. Finally, we end up coding. And which Python programming, I mean, which programming language are we sticking on to? We are sticking on to Python programming language. Even if you know Python, it is well and good. Even if you don't know Python, for today's session, whatever I'll start from now, even if you are a beginner to Python, don't worry at all. You need not worry at all. Whatever the coding snippets I am sharing now, based on the understanding you get in 15 minutes, that much is enough to understand the other libraries. So you need not worry at all about being a beginner to Python programming also. Is that fine? And the files has been shared with you already. Those who know, you can start running the code. If you don't know, you can listen and you can start working on it. Is that fine? Shall we start?
Okay, ma'am.
The screen is visible, right? Okay, firstly, I
Yes.
would like to open Collab because many people said they're not into collaborate. So you will have this collaboratory, or you can search for it, Google Collab. So collab basically means for collaborating or collaboratory. You can go to this link. So these are the recent files which I have. So it is showing. If you are new to this, you can create a new notebook. You can see the option here. You have an option to create a new notebook, and these are the files which I already have. So it is showing me the available files. Fine. So since I have already done this, I'll be using the file which I have already created. So this is visible to all now, Python Quick Tour. Can
Yes,
anyone of
ma'am.
you respond? Yeah, fine. Okay. So with respect to this, any programming language you consider, not only programming language, any language, if I want to communicate, I need to know few things. Yes or no, assume that I want to learn Japanese. What do I need to know? I need to know Japanese means I start from letters, words, sentences, something like that. So basic thing with respect to Python programming, I'll start with the data types. Okay, coming to this Google Colab, okay, this is an IDE wherein you can execute your programs. You have different options. You might have seen in different IDEs, right? The same thing, you can create a new notebook or open the available notebook, and you have access to the drive also, GitHub link, GitHub repository, all these options. You can look at it later. So you have all different options similar to your, what to say, other IDEs which are available. Now you have two options. Either you can have, these are cells. Whatever I'm seeing here, it is a text cell. Similarly, you will see the coding cell. Coding cell makes you to run the code. This text is only for visual appearance. Is that fine? Okay. Now coming to this, basically I have to learn about the types of data. What is that we are dealing with? What is it data science all about? It is only about the data. So let us learn about types of data. How do you handle it using Python? So what are the different types of data that I'm considering? Numbers, strings, printing, lists, dictionaries, tuple sets. These are different terminologies that we are referring to a particular type of data. And basic decision making statements, how do you take care in Python, and the looping constructs and the while loops and range. Is it fine? These are the basic things. Now coming to the types of data, see this data type is a cell, which is a text cell. Now coming to this, you can see an arrow over here. Now if I click on this, this particular cell will run. And whatever you see here will be the output. It is still processing. This cell is still processing and it will give you an output. So 1 plus 1, I'm directly giving the data here and trying to see the output. Again, for this next cell, I have already run the cell, so it is showing you the output. If at all you want to add statements, individual cells you can add. You can click on this code, a new cell will come. You can click on this code, a new cell will come, and you can, and if you want, you can delete the cell. So this is how you will work with collab files. Fine. So this is directly giving inputs and checking the outputs. Now we have two stars over here. How do you represent to the power in Python is you will use two asterisks. So 2 to the power 4. What is the output? 16. This is your modular division. Remainder will be the output. And how do you take care of different expressions? You will put it within brackets and you will check for the output. So this is basic representation of numbers. Now, usually I won't deal with the data directly. I'll assign it to some variable. And one more important point with respect to Python is you will not use any data types to represent the data. Name of the variable, start assigning. Name of the variable, start assigning. You need not worry about the data type or the memory requirement, nothing. Start using. So X and Y is a variable. Name of the variable is 2. X is 2, Y is 3, Z is X plus Y. So these are acting as a variables. And finally, if I print Z, value of X and Y will be added, it is printing. Coming to strings, you can represent strings either using single quotes or double quotes and so on. Now, if I want to print, I have data associated to right to left associative. The hello gets assigned to X, wherein X is a string. But I have not defined the data type of X. But hello is a string which is assigned to X. So print X, it displays the content of it. And I can do it using print statement. You have a specific syntax to be followed. Give this variable and print it. So it is displaying hello. Next, you have two separate variables. This is a cell. If I run, it will print the. I don't have a print command over here. I should print it. Print name, print num. It will display. Fine. So this is one way. One more way in which you can print. Is this font visible or shall I maximize it? You should have told no. Is it fine now?
Yeah, it was visible, ma'am. Not an issue.
Is it, okay, now also it's fine, right?
Yeah.
Okay. Now coming to this part of it, wherein I have a representation in a specific format. I have two values. One is the number and one more is a string. My number is 12 and my name is Sam. If I simply give print like this, what it will do? It will simply print hello. It will simply print the value of X. So I have some content to be displayed along with the value. So I'll make use of this flower brackets. They are nothing but the placeholders. And to fill the values in these placeholders, I'll make use of a method called format, dot format. Got it? So in this, you place the variables. What are the variables? In this place, which variable data should be printed? Num should be printed. In this placeholder, which one should be printed? Name should be printed. So assign it here. So in place of 1, 12 will be placed. In place of 2, Sam will be placed. Done? Okay. There is one more way in which you can do. You need not type 1, 2 and all. Keep this placeholder empty. This is placeholder. By default, this is the first placeholder one, and by the default, this is the second placeholder. Directly pass num comma name. So here num will come and here name will come. Done. I'll go a bit fast with respect to this so that we can give more time for other things. Then similarly, you have name, age, and this is formatting the strings. One more way in which you can print is you can use F. Directly within this, you can give name. If you give F here, you need not use format. Directly, you can start filling the placeholders with the variable names only. Got it? Next is, how do you read the data through the keyboard? Here, directly you have assigned the data. Akshay is assigned to name, 23 is assigned to age. What if I have to read the data through the keyboard? I have a specific function for it. What is it? Input. Enter your name. It will give you a prompt. This gets displayed onto the screen. I'll give Asha. And after that, what do I have? I'm concatenating strings here. One more important thing is whatever data you read through the keyboard using an input function, it will return you string always. The format for input method or a function is it will give you a string. It is going to return you a string. So name is a string. String can be concatenated. So hello Asha will be displayed. Next again, you are reading an age. How will this age will be treated? Because of this input function return value, it is treated as a string only. Even if you write 35, 25, 45, whatever it is treated as a string. I have to explicitly convert it into int because age is an integer which I need. Got it? So I'll be considering a string with respect to age because concatenation happens only with respect to string. So I'm converting or typecasting it to string, and then this is only for the printing purpose. Next, I'll read the height and then I will print it in meters. So once I run this code, it will ask me enter the name. Once I enter the name, automatically this print gets displayed. So this is because of this print statement. Hello, you are appending name. You are appending age. And here you are appending string. So accordingly, the output will be displayed. So input function, it allows the user to enter a value from the keyboard and entered value is returned as a string. So you should always keep in mind that data read through the keyboard is always treated as a string and explicit type conversion is needed. And with respect to an analogy, if I try to explain what exactly it is, you have to organize different items in a toolbox. How do you do it? You have different tools like tool, screwdriver and the pliers, or is it working? So different parameters that you are considering. So all these are nothing but the data that you are putting into a different variables. And this is representing a collection of data. Collection of data, we represent it using a list concept. And what type of data each variable is representing, that you can do it using a type method. If you type the variable name to this function, it will give you whether it is a string variable or it is an integer or a float or a boolean or it is a list. Boolean is basically either true or false. So different type of the data can be printed using type method. Now, most important thing what you should keep in mind is there are different data structures. See, I am dealing with data. So what are the different data structures available for maintaining or manipulating or organizing the data? 4 important things in Python would be lists, tuples, sets, and dictionary. I'll repeat, there are 4 different types of data structures available in Python, which helps in organizing the data, which helps in manipulating the data. So firstly, let us consider lists. So what is this list all about? It is also considering a list of data, tuples of data sets, they are also considering data dictionary also. To, excuse me, to understand this different data structures, let us imagine that we are in a kitchen and I want to organize different ingredients. Each ingredient will have a unique characteristics and you have a different containers to store them. Okay, let us explore that one by one. To understand or to remember about list, you consider a grocery bag. What this grocery bag is all about, it can store all items. Yes or no? You can put in all items. You can remove all items. You can modify anytime you want. So it is flexible. List is flexible. You can add as many number of items you want. You can remove an item or you can modify also. So grocery bag is an analogy to remember list. So flour, sugar, eggs, milk, all these things you are doing it here. Now this is the list I am telling. List is represented with square brackets. If you have 4 inputs, all the 4 units are separated by a comma and it is represented as a list. Ingredient is a list of 4 items. Got it? Directly you are creating a list and if you print, all the values will be printed. Now I have a requirement of adding one more item. How do I add? I'll make use of one more method called append. Which is the item that I want to append? Butter. So again, if I try to print along with these 4 items, butter will also be added into the list and it will display the data. Now I want to modify. See, whenever I have 4 different items, how do I refer to the first item? How do I refer to the second item? It is done through indexing. What do you mean by indexing? Assign a numerical value to each and every data. It always starts from 0. For floor, I'll assign index value 0. It is automatic. Obviously, it will always start from 0. I don't have any choice. I can't give my own number 97, 46 like that. So it is 0, 1, 2, and 3. So if I'm specifying ingredients of 0, it refers to flour. Ingredients of 1, it refers to sugar. Ingredients of 2 refers to eggs and so on. Now I'm interested in changing the first element from the list. I can modify it using the index value 0. You are giving this whole wheat flour. So at the same time, you can also remove a specific element from the list. You can do it using remove. And finally, you can print the contents. So the first list, after adding butter, then after modifying it, after removing sugar. So these are the 4 outputs which has been displayed for this. So this is all about list. List is very flexible. Add, remove, modify, everything is possible. You can do it easily. So list is a grocery bag. And similarly, I have taken one more example for different values. That's all. So this, I refer it as a one-dimensional array representation. Now let us create a multi-dimensional list. Multi-dimensional list means you have rows and columns. So see, look at this carefully. You have outermost blue colored list. That is the outermost list which is created. In that list, you have 2 items. This is one item and this is one more item. This I'll call it as row 1 and this I'll call it as row 2. And how do I access each and every element? Consider a matrix. Each and every element has a row value, column 0. The first one will be 0, 0. The next one will be 0, 1. So this is row 1. Next you go to, because this is a separate square bracket, you can see here, this is a separate row. This is 0, 0, 0, 1. Next row, if you go, the row number will change. So it is 1, 0. Got it? So this is a multi-dimensional list. And how do you access? You say matrix representation, print 0, 0, 0, 1, 1, 0, 1, 1. Here 0, 0 is hello. What is 0, 1? Good. This is row 1. When you go to row 2, this is 1, 0. Do you have 1, 1? No, you don't have element. So if I print 0, 1 and 1, 0, it will display good and morning. So this is the output. Is it fine? Next, you have different elements. It is not that only an integer, you have a string as well. So that example. And one more important thing with respect to list is that indexing can be negative. See, if I start printing list of 0, list of 1, list of 2, list of 3, list of 4, it starts from left to right. I'll start assigning the negative value from right to left and the indexing always starts from -1. If I say -1, it refers to shoes. If I say -2, it refers to 6. If I say -3, it refers to -. So like that, negative indexing is also possible and accordingly the elements will be printed. So this is one more example wherein I have created a list with so many characters. And one more important point is we have a concept called slicing. In slicing, we'll use a colon operator. Before colon, it refers to start. After colon, it refers to end. I'll repeat, in the slicing concept, before colon, whatever number you specify, it will specify the beginning. If you don't write, it always starts from 0. Before colon, I have not written anything, it always starts from 0. After colon, if we have written something, that is the end. So it will start from 0 till end. What is the end that is specified? It is minus 6. So from this, what is minus 6? See, the initial list is this 0, 1, 2, 3, 4. This is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Minus 6 is referring to C. So this is the end. When it reaches minus 6, it stops printing. So it is only till S. So elements sliced till sixth element is DATAS. This is the initial list, and the slicing done is what? Till minus 6. So it will print the values excluding that minus 6. Next is you are slicing with respect to minus 6 and minus 1. You are beginning from minus 6 and ending with minus 1. So minus 6 refers to 6. Start from this. What is minus 1? E. So it will exclude E and it will print till C. Next is what? You are taking one more third parameter. Third parameter. See, first before this it is start, after this it is end, and one more colon you are taking, wherein the third parameter it represents the skip factor. Skip by 2, skip by 5. So skipping two characters. So C, it starts from C minus 6. So 1, 2. After this, it will skip. What is this? Element slides from index minus 6 to minus 1. So minus 6 to minus 1 here, you don't have a skip factor. So all the characters will be printed from minus 6 till minus 1. Whereas in this skip factor 2, you will go here D. Then you will skip the first two characters. You will go to T. Skip these two characters. Then you will display S. Skip S and C. Display I. Skip I and E. Next N. Then these two factors. Then you will end up with E. So it is a skip by 2. Then finally, I have a requirement of reversing the list. See, I have initial list as DATA data science. I'll reverse it. I need an output like this. So for this, we'll use one more parameter wherein the last one, if you keep it as minus 1, the entire list will be in reverse order. Just highlight the last one, skip factor as minus 1. You need not highlight the beginning. You need not highlight the end. Directly, it will print the output in reverse order. So this is all about list. So list means you can add, modify, and remove. And one more thing is you can create one-dimensional or multi-dimensional, and you can do slicing with respect to list. Next, let us move on to the next data structure, which is a tuple. Tuple basically deals with a sealed container. To remember this, you consider that there are some spices which has to be sealed always, and I cannot mix anything with that. So with respect to tuple, I'll consider spices as a list. Spices as a tuple. Tuple is represented by angular brackets. List is a square bracket. Tuple is a angular bracket. So with respect to this, whenever you have a requirement of considering the data which should always remain constant, it should not change. In such cases, you will go for tuple. And here you cannot modify. It shows an error. All these are fixed data. If you want to print, you can print it. You cannot change the data within a tuple. That is what it means. See, you have created a tuple and you can give index to the tuple 0, 1, 2, 3, 4. It is same, and you can print whichever value. And it can contain the duplicate elements, but you cannot modify the elements. You cannot add. See, it shows an error. Whenever you try to add, modification is not possible with respect to tuples. So it doesn't add extra elements. Whatever you have created initially, it remains as a constant throughout. Now you go with set. Set is one more type of data structures wherein, to understand this, let us consider unique spices. For each and every container, there is a specific spice. So, and this is also represented, the set is represented using flower brackets. Different types of unique herbs, I am maintaining it in the form of a set. In set, the important thing is duplication is not allowed. Unique means no duplication. So set is a unique store. So no duplication, automatically it will be removed and it displays only the unique values. That is nothing but your sets. Next, coming to dictionary, it is basically a recipe book. For this, what is the association rule? For each and every element or an item, you will associate something else along with that. So we call it as a key value pair. Whenever you consider a dictionary, you maintain a key value pair and keys will be associated to each and every value. So for that also we'll be using a flower bracket representation wherein you have a colon. So pancake is a key. This string is a value. This is a key value, key value, key value pair. So whenever you want to access any of the recipe, you simply mention the key and it will give you the value. See, recipe is the name of a dictionary. But what is the key that you are passing? What is the associated value for it? That will be your output. So dictionaries are very important. So key value pair will be represented and they are associative. For each and every key, there will be associated value. Then we have comparison operators and you are familiar with these things and it always gives you Boolean values true or false. Then we have logical operators. If this is true and this is also true, logic. If any one of them is false and you have, so it is false. So like that you have these things. We have decision making statements. One of the most important thing with respect to Python is indentation. If you miss the indentation, you can never ever expect the output. So with respect to that, indentation is statements towards the left. See, statement yes and I, they are in the same indentation. Now if there are any statements belonging to if, it is maintained in a separate block, and the statements belonging to this inside if is maintained in a separate block. Now these two are in the same indentation. So if not this condition, automatically it will go to the else part. So these two are under the same block. You can see here code block 1 begins, that is statement 1, and the same code block 1 continues. So same S and the same indentation if is also there. But here you have a change in the indentation. So this comes under second block. And this indentation is also changed. So it comes to a third block. But else belongs to the same second block. And this statement belongs to the third block. And you have a specific functionality for each and every decision making statement. So according to the functionality, we will predict the output. If 1 less than 2, yes, print. If 1 less than 2, else you can print last. So this is how if and else decision making statement works, and you have a specific syntax to be followed. You have to end each and every statement with a colon over here. Decision making statements, if you use, it should end with a colon. And then this is an elif ladder. The functionality of elif ladder is totally different. If any one of the condition results in true, automatically it comes out of the entire elif ladder. In C programming and all, we have else if, whereas in Python we have elif. If you have multiple conditions, elif, hundreds of elifs you can write. Then coming to looping constructs. Looping constructs, you have two different type of looping constructs, for loop and while loop. You don't have do while loop. You have a list over here. You have to print all the elements. So you will make use of a variable called item. It will traverse through the entire list. What is the name of the list? Sequence. And you have a keyword called in. The sin operator, it will check for this value. If it is there, it will print that value. Item is referring to 1. 1 is in sequence, yes, so it will print. Then it will move on to the next one, 2. Then it will print. So continuous, it will be traversing through the entire list. So what is this doing here? Item. If it is in sequence, you are not printing the value of an item, you are printing the content. So how many times you traverse, how many elements are there in the list. So that many number of times this gets displayed. And then it is referring to this in a sequence. Jelly is referring to what? This is one of the variable referring to the elements in the list. So what is the first element that jelly is referring to? 1. What are the elements? 1, 2, 3, 4, 5. So jelly is referring to 1 first. So what you are printing? Jelly. So 1 plus 1. 1 plus 1 is what? 2. That gets printed. Next, jelly refers to 2. 2 is in sequence. Yes. 2 plus 2, 4. Then 3 plus 3, 6. So whatever variables you are pointing to and how you are printing, accordingly output gets displayed. Then similarly, you can use the while loop construct also if you want to print 1 to n less than 5. So 1 to 4 will be printed using the variable I. 1 is less than 5, I is 1. So you are incrementing the value of I by 1 and you are printing it using format method. That's all. So this is with respect to while loop. Then coming to range, you can specify the range of the numbers that you use. So that can be done using range in for loop. So range is always beginning with 0 and till 5. So excluding this n minus 1, it runs till 5 means n minus 1. So 0 to 4, 5 numbers. So since you are printing I, it displays 0 to 4. So these are the basic, very, very basic things that you come across in Python. So once you are aware of this, let us quickly move on to our data science related library, NumPy. Since I have all the files ready, I'm just rushing through this. Okay. Now, what is that we are supposed to deal with? We are supposed to deal with the data. What type of data is it? It is a numerical data. In such case, we'll be using the fundamental Python library for scientific and numerical computing. They are nothing but NumPy. And what does it do? It will support a large data which are maintained. It represents a multidimensional array or a matrix. So these matrices can be represented, or we can deal with this using essential library or the methods that are available in NumPy library. So NumPy is a library which has a huge number of methods or the functions available, and it is used for numerical computations. Fine, we can deal with large arrays of data. Basically, it stores the data internally in a continuous block of memory, and you can perform complex operations or computations on the entire arrays without the need for looping constructs. See, if I have to go with only Python, no need of NumPy, means for each and every matrix representation also I should run a for loop, multiple for loops, track each and every element. But what is the advantage of NumPy? It provides a huge set of methods in this particular library. You will see that now, wherein this can be efficiently used without extracting each and every element using looping constructs. You don't need to use looping constructs like normal Python programming. Start using the available lists of functions or the classes that are available in NumPy library. Here we refer it to the elements with respect to an array. Whatever list we say, we refer it as a array. Group of elements are maintained in an array. And for that, you have dedicated methods or classes which are doing that particular job. You have this variable or the library NumPy associated with it. You will import this library and you will create an alias for it. You will create a new name for that particular library, import all the available methods in that particular library and start using it. So once you import that particular library, you can use array method, you can use zeros, you can use ones. And how do you call it? Dot. NumPy. If you have created an alias, usually we name it as np.array, np.zeros, np.ones. So these are the methods you should be familiar with. What this array will do, this will create a list of elements, and zeros will create a list with, and all the and that particular array will be filled with zeros. Next you will create an array and it will be filled with ones. Next you will create an array and it will be empty, and you have to arrange the elements. You have to provide space or fixed number of elements. So different methods are available. And if you want to know the dimension of an array, you can use the shape method. And if you want to reshape the array to a new size, if it is 2 cross 2, if you want to make it 3 cross 4, reshape it. And if you want to merge two arrays or concatenate, use concatenate. So similarly, you have different methods available under NumPy. And if you want to add the arrays, use add method, subtract, multiply, divide. You need not write any code to it. Start using the available methods. That is why Python is very famous, or it is in boom now, wherein you have all the libraries, necessary libraries, name anything. For each and everything, you have the libraries available. You need not think, sit and code. You have to code, but for each and every task, you need not write line by line logic, whereas you do it in C programming. For each and everything, you have an associated method in a respective library. Import that library wherein all the methods will come, start using it. So these are some of the mathematical functions. You can use log or square root or to find the minimum, maximum, variance, standard deviation, mean, sum. These are all your statistical functions. Next, you can randomly generate the number using random. In this NumPy library, you have a method called random, and a submodule is named as rand. Rand n stands for normal distribution, and specifying the random integers range, and then choice, and then you can also take care of array indexing and slicing, how we discussed in list, the same thing. And you can also have some of the universal functions, sine, cos, and absolute values. And linear algebra inverse, you can calculate determinant of a matrix, eigenvalues. You do not write code for all these things at all. Start using it. And percentile, histogram, coefficients, and you can also save the model or load the model binary file if you are using, and some of the trigonometric functions. So this gave you an insight into NumPy libraries and how many different model methods are available. All the methods are available. Just start using it. So let us look at it one by one. I have to create a shelf with a library. So what is the first step I would like to do? First, I will import all the files from this library NumPy. What is this NP doing here? This is an alias or a name created to this NumPy. You are importing all the libraries, all the methods present in NumPy library, and you have created an alias, which is nothing but a new name given to this, so that whenever you refer to the method, you can give np.array. Got it? It is referring to the NumPy only. So I'm creating a list over here. So this list has 5 elements, and this array is a method. So you have this angular brackets, and within that you are creating an array with 5 elements. Now you print the array. Where is it stored? It is stored in a variable called my_array. You print it, it will display the output. Now I want to know the dimension of it. How do I know? I'll start using a method called shape. So it will give you the length, width, and height of the room. For example, if you have a requirement like this is just an analogy. If I want to know the shape, so what do? I'll print the shape. So what is the shape? It is 2 cross 3. There are 2 rows and 3 columns. So this is giving you the dimension of the list. Next, in the same way, if I have a requirement of calculating the mean or average of the array, I'll call the function mean. How do I do it? You pass an array, a list of elements, and calculate the mean. For mean, what you are passing? For mean, you pass the input. What is the input? Who is holding the input? Data is holding the input, which is nothing set of all the elements. And mean will take care. It is the headache of mean to use the formula and calculate the mean. We are least bothered about what is the formula and all. I only need the mean of these data. If it is 5 data or 500 data, finally I need the mean, and it is stored into a specific variable, print. Next, coming to this maximum value and minimum value, you have a list of 100 values. Which is the maximum among all these values? I need not write a code. If I have to write a code, I should start writing decision making statements. Either I use a sorting technique and then I find the maximum, or I will use linear search and then I will compare 2 values and I will find the minimum. You are least bothered. You need not worry at all about any of the logics in the program. Start using max function, min method, or max method or min method. For what you have to find the heights? Who is holding it? Height is a variable which is holding all the data. Pass it as an input. Now input the heights. It gets displayed. Who is the tallest among all this? 180. Who is giving you this data? It is the headache of max method. It will give you 180, and min will find out which is the minimum or the least among this, and it will give you 150. np.sum, it computes the sum of array elements. So basically you have to add up all the elements. If you want to know the scores of basketball team and each and every point that is there maintained in the list, and I want to know the scores of a team. So that can be done using adding up all. You need not write any logic wherein you use a for loop, extract each and every element from the list, use sum equals sum plus I, and add up all these things. Not at all needed. Directly use sum and get the job done. Then you have this dot product. Basically, it is the dot product of 2 arrays. You have to multiply it, right? So with respect to that, you are taking 2 arrays over here or 2 lists, multiply these 2 matrices. So with respect to that, multiplying, and then finally you are getting the output. And then you can generate random numbers. If you want to generate integer values, specify the submodule as randint, and then if you want to specify the range only between 0 to 1, you use rand. So dicing 6 dice, rolling a die. So with respect to that, or if you want to draw a random card from a deck, so keeping those examples in mind, you can say that you are generating a random integer between 1 to 7. So what is that we are trying to do over here with respect to NumPy? We are not writing a logic for each and every need. We are realizing which function will do what. Which function I should use when. That is what is your job with respect to NumPy. You are not writing any code at all. Understand the requirement, extract the respective method. Who can do this job for me? Call that particular person. So similarly, in the same way, which function is capable of doing this job to me? Call that method and give the data. And everything has a specific syntax. Follow that syntax. Import the module, call the function, and pass the data. So accordingly, you will get the output. So similarly, the same thing I have given as an example over here with respect to an analogy, and each and every print statement is added wherein one-dimensional array is represented and two-dimensional array is represented, and you are printing the data. That's all. Here np.array one-dimensional array is created using same np.array two-dimensional array. How is it possible? See, this is one list, pass one more list, pass one more list. So multiple lists are acting as a multiple rows over here. So that becomes a two-dimensional array, and it is done using array method itself. You can create an array, multi-dimensional array. Then coming to this data in your baskets, this is basically adding. If you want to add a specific element, you specify the name of the variable, simply plus 2. What is this doing? Each and every element gets added by 2. See, 2 plus 1, your output should be 3. 2 plus 2, 4. 2 plus 4, 6. 2 plus 5, 7. Like that, each and every element in an array gets added with this. So in the same way, if you want to multiply a specific value, multiply by 3. So accordingly, you will get the output. Element-wise operations, you can do it. You can multiply to arrays as well. So this is the output. And then slicing also can be done. We have come across this slicing operation, right? 1 to 4. This represents the beginning and this represents the end. Slicing is nothing but it starts from 1. Indexing is always from 0. So 0 is ignored. 1, 2, 3, 0, 1, 2, 3. So this is with respect to whenever you specify, it is up to that particular point. It will stop whenever it encounters 4. So 0, 1, 2, 3, 4. Whenever it encounters 4, it will stop and the remaining elements will be displayed. So it is 2, 3, 4. This is the end. Whenever you come across this index value, stop it. And start from this, start from 1, end at 4. And then calculating the summary. Okay, coming to the statistical summary. If you want to find the statistical summary of the inputs that you have, start using the methods. What is that? You have a mean method, use it. You have to find the maximum element, use max method, pass which is the input. From this input, you have to find the maximum value. So like this. Next, you have the Boolean indexing analogy. You want to know whether is it true or false. So such things can be done using this, wherein you are specifying the array elements and then check whether it is greater than 3. If it is true, array 1, is it greater than 3? If it is false, no. Only when it results in true, you will print that particular data with respect to the index value. So this is the condition, it should result in true. If it is true, array of 1 will be displayed, array of 2 will be displayed, or array of 3 will be displayed, and accordingly this is the output. This is similar to your the same thing, multiplication of 2. So coming to your data analysis part, what you have to do? You have sales data and you have to calculate the total revenue. And what is the library that you use? NumPy library. So sales data, I'll consider it like this. And then I have to calculate the revenue. How do you calculate the revenue? It is the sum of sales. So I'll be using sum method. So here the terminology used is very different and very technical, saying that we are doing something called as data science job, wherein calculating the total revenue. And what is it? It is simple method wherein sum is doing the job for you and printing it in a different way. And how do you deal with the missing values in a data set? So with respect to that, we will try to find the mean. Whenever you are dealing with the missing value, see, this is the data set. Wherever I have np.nan, not a number, see, this is standard. You have to write like this only. If any values is missed, it should be represented like this, np.nan, np.nan. So I have a data set, but few values are missing. How do I deal with it? With respect to this, I have a method called mean, but it is what? Replacing the values with the mean. Calculate the mean and replace it here. Calculate the mean from the entire data set. You have so many values. From this, calculate the mean of it and replace in the place wherein you have np.nan. So that is done using this nan. So mean value has been calculated and it has to be put in where is nan data. See, is nan is a method wherein you will check whether it is nan. Is 10 nan? No. So you will not replace it here. Is this nan? No. Is this nan? Yes. Only in this place you have to place the value of mean value. Data of 0, data of 1, data of 2, data of 3, like this with respect to the index value. Is it nan? If it is true, you will place it here. So that is how you will be handling the missing values using NumPy. Next, sampling is with respect to randomly generating this. So you have a choice whether I have to replace when there is a duplication or not. So you have 5 random values and you have the data selected. So accordingly, you will print the sample by randomly selecting 5 data points. Do you want repetition? No. So that is why you have given false over here. So these are very minimal functions that I have selected as an example and shown you with respect to NumPy. So I think this much is enough with respect to NumPy. The more and more problem statements or the need you come across, you will try to use the other methods available in NumPy. See, reshape you want, or you want to subtract or multiply, or you want to find the minimum, or you have the requirement for log or square root or dot product or random or any of the linear algebra equations that you are dealing with. So all these things can be handled using NumPy. Shall we move on to the next one? Okay, wherein okay, coming to pandas. Till now, we have learned about numerical computations using NumPy. We have lots of library, I mean, lots of methods available in NumPy library. It is limited to numerical values. Now I will deal with a table data, a tabular data, which will have all different types of data. It is not dedicated to numeric values. You can have any different types of data. Got it? So that is represented using pandas. Pandas will also provide you a library. I mean, Panda is a library which provides you different methods to handle this tabular data. And this tabular format is referred with a name called data frames. Data frames represents the entire table, wherein series represents a specific column. So data sets in pandas, they are usually multi-dimensional tables and they are called as data frames. So entire table is called as a data frame in pandas. And each and every column is called as a series. In a table, if there are 10 tables, a table, if there are 10 columns, each and every column is referred as a series. So coming to that, let us get into an example wherein we have this dictionary. I told you, we have a key value pair whenever you consider a dictionary. So this is represented in the form of a table. So you have rows and you have columns. So with respect to this, I have a method called data frame. This will do the job of setting up a table. It creates a data frame. From what you are creating a data frame is basically a table. You are creating a table from the variable you have passed. What is this variable referring to? This variable is referring to a dictionary. What is this dictionary? It is a collection of key value pairs. This is a key and these are the values. For names, you have a list. Each and every key can be of different types. So it is a list and age is a key. And what is the value associated with this? You have so many values and this. So you are creating a data frame means you are creating a table for the dictionary. Now, if you print, it will print in this format. See, is it not looking like a table now? You have different rows, 1, 2, 3, 4, and these are the columns. You have 3 columns. And what are the names of the keys? Name, age, grade. That is acting as a header over here. So this is a particular data frame. You have created a data frame. Now, how? By using dictionary as an input. Is it fine? So name is a series, age is a series, and grade is a series. So all these are series. This entire thing is called as a data frame. How do I filter the data? See, I have created a data frame. This is for creating a simple data frame using partners. Now I have to filter the data. How do I filter the data? I have some condition. What is my condition? My condition is if the grade value is 11. If the grade value is 11, you have to print only that particular data. So I am filtering based on a condition. What is this? This is the, now look at this. Who is in grade 11? Alice is having grade 11 and David is having grade 11. So out of this entire data available, depending on my requirement, I have to extract only this information, only row 0 and row 3. How do I do it? I'll check whether the grade is equal to 11 or not. So that is done using this. So how you are representing a data frame? Data frame is represented with DF. See here, you have created a data frame and it is assigned to whom? DF. So you take this DF. So this DF is taken, and in this DF, which series you want? You want grade series. And what is it? It is a string. So you are taking this series. So from this particular series, which value you want to consider? Check whether that series value is 11. Now DF of grade, go to this. Is it 11? Yes. If it is 11, what will you do? DF of this particular row should be printed, DF of 0. This gets printed. Next you will check with this. Is grade equal to 11? No. Then this will not be printed. DF of 1 will not be printed. It returns either true or false. If it is true, it gets printed. If it is false, it will not be printed. So accordingly, you will print 0 and 3 because it is matching with this particular condition. So that is how I am filtering the data. Now, how do I add a new data? So this is my key value pair. This is key, this is my value, this is my key, this is my value, this is the key, this is the value. I want to add one more key value pair. How do I do it? I'll do it using append method. Append is a method wherein I can insert values to it. Now, new student is what? New student is this one. This is the new student. Whatever was the previous one, this data, this was the data. Now for this data, I'll try to add one more value. What is that? Name, age and grade. You have name, age and grade. Name, age and grade. This should be appended. And how do you append? After David. So it has to be appended after David. It means that which is the next index value? 4. In index value 4, this should be appended. So how do you do it? This is equal to true means next available index. Go to next available index and insert the value. If you do it twice, it will display it twice. So this is how you will add the data or append the data. Now coming to the sorting. So you have to sort by age. So you will be using this wherein you have sort values method for the data frames you are assigning. And how will you sort it? You will use by class and then keyword. With respect to which series, with respect to age series, you are doing the sorting. Who is doing the job of sorting here? Sort values is doing the job here. Based on which series? Based on age series. See here, age is increasing order. So it is sorted. So this is with respect to sorting. Then how do you analyze? You have to count the number of grades. How many are there with grade 10? How many are there with grade 11? How many are there with grade 12? So that is done using value counts method. And which series you are considering? You are considering the grade series. So this particular series, grade 10, how many are there totally? It will do the sum and it will give you, it gets stored into the variable grade count. So this is how you will do it. So these are the basic things. And here we have done it with respect to what? Direct inputs like this. Here the input is very limited. Now assume that I have thousands of data like this. Can I type it here? Can I type all the 1000 data like this and assign it to a variable new student equals name 1, age 1, grade 1, name 2, age 2, grade 2, name 1000 like that? So instead of that, I'll store it in a file. So that we call it as a CSV file. To demonstrate that, I have maintained those CSV files in Google Colab itself. See, if you have, so it's already 12 now. I'll rush through. Okay, I'll just give you an overview what exactly we are trying to do. So far, whatever has been done is we have these things maintained here itself with different variables. Now I'm trying to consider thousands of data wherein I can't write all those things. I'll maintain a CSV file, and that CSV file, I'll try to show you where exactly I have maintained that particular data. I have my drive here. I have so many folders. In that I have a particular folder called data science. Data sets, data science. In this, I have so many CSV files. All this will be shared with you. See this crime data.csv, crime data, all this has been created and it does not have more values also. But assume that it has thousands of values. This is the table. It has so many values. Like this, you can maintain thousands of values. Got it? So this is a separate CSV file. So what I'm trying to do with this collab file over here is I have to mount the drive. It means that whatever files you have in this collab Google Drive, you mount it so that you can access the files in it. What is that I am importing? This drive. See here towards your left, you will be having a folder icon. This takes a few fractions of seconds so that to display the content of it. I'll try to mount this. I have to run this cell. This is the code wherein you have to mount the files whichever you have it in the drive. You have to import it from where? Google Colab. So to Google Colab, I am mounting the files wherein I'll run this. I have to connect it to Google Drive. It is asking me, yes, you have to connect it to Google Drive. And it will ask me through which account. Always I should log into Gmail account. And then through this, I'll give access, allow this to import the files from Google Drive. So this is the first basic step you have to do if at all you have a particular data set. And store it in any one of the drive in your Google Drive. See, I have a folder. In that folder, I have maintained all CSV files. I have to extract this to my code. So what will I do? I'll come back. I'll mount it. So you have this tick mark. So it has been mounted. So once if it is mounted, it will display here. So what is that I need? Drive. See this drive. This was supposed to be mounted. Now it is visible. Previously it was not visible. Now if you see this drive, what was it? What is the name of this? This is my drive. So in Gmail, I have a drive. What is this name? My drive. In that I have dataset science, datasets, data science. So within that one more folder I have. I'll search for that here. See, I have my drive. In this, I have so many folders. In this, I have one data sets, data science. In this, check here. All this has been imported here. Now your Google Colab has access to all the CSV files. So all the CSV files are here. Fine. So now what I am supposed to do, I have to import this file whenever I am in need. So if this is clear, I'll close this part and let me rush through this. So basically, I have to read a particular CSV file by specifying the path. See, this is the path I have to give. To give this path, you need not worry. Go to this file. See, I want to extract this crime.csv. Click on this. You have an option, copy path. If you copy path, this entire thing I can replace with that. Control V. See, I'll try to replace the path over here. See, can you see the content here? I did not type. It is the path which I copied and it is displayed over here. Can you see this path? So this is how I will give a path to each and every CSV file which I am reading. And with this, I can read the data in this particular file. See, whatever data you have, that gets printed. This is the file and I'm reading with respect to pandas and I'm printing it here. These are all with respect to the data directly you have given. What about the data if I give it through CSV file? This is for the understanding I have included. So this is the exact code wherein crime data I have taken and I'm printing the data set. And head, this head method will give you the first 5 entries, topmost. And it will give you the entire information of the data set. See, this is the data set. If you want, I can print that as well. Crime data. So this is how your data set looks like. See, you can have a look at it on the right side wherein crime data.csv is shown. And this is the data set which is printed. And head means since I have only 5, all the 5 reports are displayed here. If I have 100 rows, out of 100 rows, only the first 5 will be displayed. That represents the head of the data set. And then data filtering selection, as I told you, the grade is equal to 11. In the same way, if you want to select the crime type, whichever there is only robbery which has happened, and if the status is suspect, only that thing you have to display. So case ID 246, case ID only 246 has suspect. So which is suspect here? 246. So you can directly get an access to all the status whichever is suspect in this, and whichever is the robbery case, which is arrested, which is suspect. So based on this thing, you can select the specific row which is needed, and then you can go with cleaning the use cases. This is an example with respect to data which you are directly giving it here. And one more important thing is np.nan represents the missing values, and you have to give it like this only. Okay, now coming to the actual code of it, this is the code wherein I have used CSV data. And here I have one more parameter which has to be taken care here whenever you are dealing with NaN values, is you should always treat NaN stands for not a number. Whenever you come across NaN in crime data 1.csv, assign it to NA values. That is the explicit one more parameter that you should add it with read CSV. Whenever you are reading a CSV file, wherein if you come across np.nan, I have one more data set to show this crime data. I'll close this. So here, see, I have added np.nan here. Explicitly, I have added for a separate data set, wherein whenever you have np.nan for that particular data set, how do I handle? When you come across this crime data 1.csv has np.nan. Yes, it has. So what I'll try to do is I will try to drop that values. So what is that? Whenever you come across a table or a data frame which is having any of the rows filled with np.nan, you try to drop it. This is the method used. This is how we will clean the data using drop na method. See here, data set after cleaning. This is the data set after cleaning. And where do you have NaN? 104. So 104 is not there here. And where do you have NaN? 103 is also not there. So it has been cleaned. Wherein who is doing the job of removing or dropping the rows with NaN? This drop Na is doing the job. Is it fine? And how do you give instructions to this? When reading the data set itself, whenever you come across np.nan, this is important. Without this, your code will not work. So this has to be taken care. And then aggregations and summarization, wherein you will merge the data set. See, for example, you have two different data sets, suspects data and one more data set. Both of them can be merged. Based on what? Based on one factor. See, suspect ID should be there in data set 1 and data set 2. In both the data sets, I'll be using one unique column, suspect ID, which will be there. And then what I'll try to do is I'll try to, based on this suspect ID, I'll try to combine two data sets. This is data set 1 and this is data set 2. See here, this is crime data. There is no np.nan. This is crime data set 1, wherein np.nan is there. I'm trying to combine these two data set wherein suspect ID is common in both. So suspect ID, based on this, till here, first data set will be named as X, second data set will be named as Y. So you are combining both the data sets. How you are doing that? Using merge method. Got this point? Based on what factor? Based on suspect factor. And which are the two data sets you are merging? This data and suspects data. These are the two names given to two data sets. See here, first data set is crime data.csv, second data set is crime data 1.csv. These two are given to which variable? After reading the content, suspects data and data. So here, see, first parameter is data, second parameter is suspects data. So two data sets are supposed to be merged based on what key? Suspect ID, and this is the merged data set which is shown as an output. And visualization, you can plot it using any of the type of visualization plotting charts. And this is how for each and every crime type, you will count the total number for crime type. For example, if it is burglary, what is the count? It is 2 somewhere. If you count here 0 and 1 here, in some other data set, it might be 1 plus 1. So it will give you 2. Then robbery, it is only 1. And then assault, it is 1, like that. So depending on the number of arrays that gets added, that is nothing but your value count. And what type of graph are you plotting? You are plotting bar graph. So this is the main thing with respect to pandas and how we can use different functions and with respect to CSV files. So with these examples, I'll take 2 minutes on visualization as well. So matplotlib library, it is basically to give you a visualization for any of the type of data that you consider. And you can plot n different types of charts. See this, you have the day lists maintained over here, and it has a specific syntax to be followed. Each and every method has a specific syntax. Start assigning the values to it. That's all. So which are the two lists that you are considering? Fine, x and y are the two inputs, x-axis, y-axis. Then you have to say what has to be the label of the chart. So it is line plot. And what should be the line style? It is single dash line. And what is this marker O is representing here? It has to be a dot kind of a thing or square kind of a thing. And what is this color blue representing? And then marker size, what is the thickness? It is 5. So this plot is a method. It is representing line plot. So if you call this method, what type of graph will be plot? It will plot line plot. And what is that title? What is the title you want to give? And what is the label that you want to print here? See, like this. And what is the legend and green, I mean, what is the grid that you want at the background? So all these things you can do it using, and you have to import this file. First of all, it is a submodule pyplot, and you are giving an alias as plt. In matplotlib you have a submodule called pyplot, so you are importing that and giving an alias as plt. So plt.title, plt.plot. Previously it was np, then like that. No, so similarly in matplotlib you have like this. This is line plot. And coming to one more different way of line plot, this is dashed line. So no changes, wherein you have just changed the line style over here, line style, and you don't have a grid over here, so there is no grid. Sorry. Then you can plot a bar graph. What is the change? You will simply change the name of the graph over here. That's all. Which method you are calling? You are calling bar graph. So it displays a bar graph like this. And coming to the histogram, this is similar to your bar graph, wherein you will not have any spacing between the, and what is the name? You will call hist, and you will be passing different parameters, how many bins you need, and what is the edge color you want, what should be the weight, and all those things you will highlight over here. And this is with respect to histograms and bar chart. And scatter plot is how there is a variation in your data. To highlight that, we will go with scatter plots. And then finally, you have this pie chart representation. See here, with respect to different inputs. This is the classification, and I have an example. Okay, one more important thing is you have box plot, and it requires some what thinking over here to understand. See, this is a box, and all the values that you give as an input, median will be calculated. That median will be represented with the highlights in between this box. So that is the median, and towards the left side is the lower quartile, and upper one is the upper quartile. And with respect to this, you have a look at this. I have two schools and a test has been given. Performance of all the students in school A is plotted like this. Performance of all the students in school B is plotted like this. Their performance median is calculated and it is around 87. So for the school B, it is 85 or something like that. So this is how you represent, but this is not as simple as your previous plotting things what we have seen. Where majorly it will be applicable is continuously see these values. See 85, 95, 70. Assume that I'll try to add some 200, some drastically changed values. This I'll call it as an outlier. Outlier means it is not belonging to this class. It is totally different from the existing category. So if I try to run that, see here, this is an outlier. There exists an outlier here. There exists an outlier here. So this kind of representation can be easily done using this box plot. So this representation is quite useful, such things. And let me quickly, okay. This is one of my favorite. Okay. Basically, once we are done with all the data handling aspects, we will come across machine learning. And once if you want to come across, once if you really want to learn machine learning, the associated terminologies will be AI. AI is same as machine learning. Deep learning. Deep learning is same as machine learning. Are they three same? So this is the confusion we have. No, they are not at all same. They are entirely different. Wherein artificial intelligence, we refer it as a human intelligence exhibited by machines. That is the standard terminology or the standard definition. But how do you achieve this? This is achieved only through machine learning. And what is deep learning then? You are implementing machine learning using deep learning. And there is a limitation with respect to machine learning, and you can handle all the unstructured data and all using neural networks comes into picture with respect to deep learning. So these things and all, I'll just try to skip wherein you are, I wanted you to have a feel wherein AI means John McCarthy should come to your mind. So examples of AI should be your self-driving cars or sign or voice recognition for impaired people and humanoid robots, and machine learning means you should remember Arthur Samuel. So ML comes into picture there. Then you have so many apps available, so many filters. They are all following machine learning. How your Netflix is able to recommend the movies, they are all based on ML models. And whenever it comes to deep learning, it's Jeffrey Hinton. So whenever it is deep learning, always you come across neural networks. You have so many hidden layers. You have the input layer, output layer, and you have all different deep learning technologies adopted in virtual assistant, facial recognition. You have to train the model, and learning procedure is called as a deep, and how much data is trained, all those things. And some of the examples of deep learning would be your virtual assistants or driverless cars, chatbots, facial recognition, and you have so many shopping and entertainment sites. So that is all about introduction to AI. And coming to the machine learning part of it, this is what you are supposed to highlight or concentrate more on. In one of the slides, I said the machine learning means you will come across supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, basically you will be under the supervision of a teacher. Assume like that. In the same way, your model will be under the supervision. Your model needs the supervision. It is similar to a student who learns from a teacher. This is called as supervised learning. Now consider this. You have a data, and this data is different shapes. And each and every shape is labeled over here. You can see hexagon, square, triangle. Now your model has been trained with all these different labels, with all these different shapes associated with a label. Now I'll give a new test data. I will not give the label. I'll simply give some shape. But based on the training which has already been obtained, your model should be able to predict the first shape I gave is a square and the second shape I gave is a triangle. In the same way, I will give you all the animals with a label. Your model gets trained. I'll give a new data, which is a test data. Your model should be able to predict. So supervised learning means label is associated with it. Next, you consider one more example. I have different coins or the currencies, and each and every currency has a specific weight associated with it. And your model will be trained. 3 grams means €1, 7 grams. If I give a new coin, it should be able to predict me the what is the label. You have that currency with the gram. So that particular currency will be predicted. Now, basically, with respect to supervised learning, we have two types of problems: classification problem and regression problem. So classification is basically when the output variable is categorical with 2 or more values, yes or no, you want to classify true or false, then you can go for classification. Regression means when there is a one variable associated with the change in another variable, you are really establishing the relationship between the variables, then you will go with regression. When there is only yes or no, true or false, you will go for classification. Assume that you have to classify spam mails, whether it is a spam or non-spam. So with respect to that, you will scan the entire document and you have to categorically specify whether it is spam or non-spam. This is one of the example of a supervised learning wherein classification comes into picture. For weather prediction, you have to know the temperature and it has to learn the humidity, all these predictions it has to be done, and it will predict the temperature. This is weather prediction, which is treated as a regression problem. And supervised learning examples can be classification or regression, or you can look at risk assessment, fraud detection, and also visual recognition. Now coming to the unsupervised learning, this is without labels. You will not at all be provided with any of the labels. So what you will try to do, group of vegetables or fruits like this, your model should be trained, and it should be capable of categorizing it. See, did I give any label over here? No. What is the hidden agenda over here? You are discovering the patterns. What is the information available in this? So you're trying to work on the patterns and then you are trying to categorize it using unlabeled data that is specified as unsupervised learning. So here you have an input data, your model can see the pattern. See, this is also of this shape, this shape, this shape, similar shapes, but I'm not giving any label. So identify the hidden pattern and then try to classify it. With the similar features or similar segments, there will be some implicit patterns associated with this, and that is how you do the calculation. Now take cricket as an example, wherein you have to categorize or differentiate batsmen and bowlers. I will not give the input as a set of batsman list and set of wickets. I will only, bowler's name. What I'll try to do is I will plot a graph. All the people with high runs will be categorized together. They will be treated as batsmen. All the bowlers who has got more wickets, they will be categorized separately, but without even assigning a label to it. By plotting this graph, I can analyze the pattern. Who has got more runs, I'll treat them as batsmen. Who has got more wickets, I'll treat them as bowlers. So that is unsupervised learning. With respect to unsupervised learning, we have clustering and association. There you have classification and regression with respect to supervised learning, and with respect to unsupervised learning, you have clustering and association. Clustering is nothing but similar objects and dissimilar objects. You make it as a separate cluster. Association is based on the probability of occurrence, you will group them. So clustering, you can cluster depending on the call duration. You can classify different types of users, whether the internet usage is more or their call duration is more, like that you can cluster. And how you can associate is you can do the recommendation system over here. See, for example, if you consider customer 1, if he is buying bread, you can always suggest him, he can buy milk also, he can go with sugar or he can go with butter, and what kind of data is it associated with. They are all groceries items, or they are vegetables, or they are clothing items. So like that you can associate one type of data to another type of data. That comes under association. Without even labeling it, you can establish a association. So that is nothing but your unsupervised learning. And then comes your reinforcement learning. This is basically with respect to learning from the feedback. So whatever feedback you give, take that as an input and try to enhance your system. So learn from the feedback. So I'll give you an apple. Firstly, your model will predict it as a mango. Then I will give a feedback. No, it is wrong. It is an apple. So that will be learned by the model. Then finally, it learns based on different parameters, colors, texture, size, weight, and all those inputs. If you give, finally it will be able to predict it as a apple, as an apple only. And what type of learning is it? It is reinforcement learning, wherein it is learning through a feedback. That is how a child learns, and you will always give reward to it, and this process comes under reinforcement learning. So now let us try to check what type of scenario comes under which type of machine learning. For example, Facebook face recognition, or Netflix movie recommendation, or fraud detection. What type of scenarios are these? Facebook means what? If you have to recognize your friend's picture in an album, what type of machine learning will we use? Or if you are recommending some new songs, what type of learning? Is it supervised, unsupervised, or reinforcement learning? So basically, when you come with face recognition, it is supervised learning, because for each and every face there is a name associated with it. And recommendation of songs with respect to specific genre, you will or the trend, you will have the classification done for the songs. So that also comes under supervised learning. Whenever you consider suspicious transactions, can you label them? What type of transaction is it? Is it fraud or not fraud? You cannot directly label it. Depending on the analysis or the pattern that is induced into the type of transactions that is happening, you can say that it is supervised or unsupervised learning. Here you cannot define this is suspicious transaction, this is like that. You cannot label it. There are no labels like fraud and not fraud. It will try to learn by the outliers. If it is a normal tendency, that will not be an outlier. If there is something very different from the usual analysis, that is treated as an outlier, and through that you should be able to predict it as an anomaly or suspicious transaction. So these are the things which I thought for today. And So I'm done with the presentation now with whatever was planned. Thank you. Thank you so much.
Thank you so much, ma'am. Really, it went well. I think so. We are running out of time, but still we are
Sure.
having next